Alright, in this set of videos, we're going to review logarithms, just kind of all the important stuff we need to know for the next kind of calculus topic. We're going to need to use logarithms. It's also something we'll have to use throughout the rest of the semester and on the AP exam. So I just want to take one kind of day to review logarithms. Alright, so we're going to start off with the basic definition. Alright, the basic idea is that logarithms are the inverse of exponentials. All right, so if you plug something into an exponential, you get that out of a logarithm. All right, so this is the basic idea. We have our exponential with base a. So if we switch between an exponential and a logarithm, the bases are going to be the same. All right, the input for the exponential, if that's the exponent there, that becomes the output over here for the logarithm. And the output for the exponential, the thing you get out, is the thing you would have plugged in to the logarithm. So remember, inverses just kind of flip the x and y. All right, so if we go between exponentials and logarithms, we just kind of flip where those two things are. And for e, just remember, it's just a symbol. It's kind of upsetting that they used a letter instead of a kind of Greek letter like they did for pi, but e just ends up being a number. You can see it here. It's about 2.718. All right, there's a whole big definition with e that you don't really 100% need to know. But remember, e is important for a lot of reasons, but for us so far, the most important thing is that if you take the derivative of e to the x, you get back its own derivative. You get back e to the x. All right, as long as you're doing like things like 2 to the x, all right, you get 2 to the x, and then you have to add that extra natural log of 2 part at the end. All right, so there's some extra stuff, but with e to the x, it's just its own derivative, which is nice. All right, so just to wrap up this first part, all right, using the definition, all right, what happens when you plug certain things into your log? All right, so log base 2 of 8 equals what? Let's just call it x for now. Using that first slide, the fact that logs and exponentials are inverse to each other, I can think about this as an exponential 2 raised to the x power equals 8. So basically the answer is whatever exponent I put on 2 to get 8, and that ends up being 3. All right, log of 1/10, remember that's a special common log, so that's technically base 10. So 10 raised to what equals 1 over 10. And if you remember your exponent rules, if I put in a negative exponent, that's what turns it into a fraction. So this answer is going to be -1. All right, 10 to the -1 flips it to the bottom of the fraction and makes it 1/10. All right, the natural log of -1. Remember, the natural log is just a shorthand for log base e. So we can get e raised to what equals -1. And if you were to look at the graph of e to the x, all right, it looks something like this. All right, it starts off small and gets really big. And e to the x is never down here at -1, so this never happens. All right, e to the x never equals -1, which means if this never happens, this expression doesn't make sense, so this does not exist. All right, one thing we kind of mentioned really early on in the fall, we might have said it 1 or 2 times since then, but one important thing with logs with any type of log, whether it's the natural log, common log, any other log, you can't plug in 0 or negative. So the natural log of -1 doesn't make sense for the same reason the natural log of 0 and the natural log of -10, all these would not exist because you can't plug in 0 or negatives. So this is the really kind of bare bones part of logs. What is the definition? Just remember they're related to exponentials. That might help you. And then when you're kind of evaluating them, you're thinking about exponents all the time.